We'll now see the condition for a plane to be tangent to a cone. That is, we find the condition this plane which passes through origin should touch the cone. This is the quadrigon which also has, which also pass through the origin, or in other words, whose vertex is 0, 0, 0. Now we shall consider x1, y1, z1 to be the point of contact of the cone and this plane. Name this equation as say star. Then the equation of the tangent plane at x1, y1, z1, which we have already derived. So we have that to be this and name that as double star. Now this plane and this plane being the same, because we are given that this one touches and this we know already to be a equation of the tangent plane. So because they represent the same plane equation, we can identify them. So when we identify, this is what we get. We have ax1 plus hy1 plus gz1 upon L, because here we have L, and the same hx1 plus by1 plus fz1 upon M, and then gx1 plus fy1 plus cz1 upon N. So we have compared these two and we have got this set. Now we can choose this as say some k. Each ratio we can have it as some k, so that we will have keeping this and then taking this to the other side, cross multiplying. This is what we get for all the three that we have. But we know that x1, y1, z1 also lies on the given plane. So we have another equation. So this is these are the four equations that we have, and eliminating this x1, y1, z1 from those four equations, we get determinant A, H, G, L, H, B, F, M, G, F, C, N, L, M, N, 0. This is 0. Now when we expand this determinant, this is what we get. When we expand this determinant, fourth order determinant, this is 0. So along this, when we expand, first one will not be there because 0 is there. So like that we can expand, and when we simplify, these are the terms that we get. Now we can rewrite these terms in this way. Capital A L square plus B capital B M square plus capital C N square plus 2F capital F Mn plus 2G capital G N L plus 2 capital H L M equal to 0. Where here this A stands for BC minus F square and B stands for AC minus G square. Capital C stands for AB minus H square. So and then F is nothing but minus AF plus GH. Capital G stands for minus BG plus FH, and capital H stands for minus CH plus FG. See here you can see that L square term that arises from here, BC L square, from here you will have L square term, and then here F square term. So BC minus F square, what we can do is, because we have 0 on the right side, we can multiply throughout by negative sign, so that plus this will be, and this will be also plus, and this is minus, plus, minus, minus, and then here too we have one minus, plus, and plus, minus, plus, minus. So when we compare this, plus BC minus F square plus BC, this is minus F square. So that BC minus F square that we have, in the same way you collect the terms containing M square. So this becomes plus AC M square, and this is with a negative sign, minus g square. So this is how we get. And why we need it in this form? See, this is the required condition. We are given Lx plus My plus Nz equal to 0 to be the plane, which means the given cone equation is given by this. This is the equation of the cone. So once these two are given, the condition required is the same thing with small a, small b, small c. All these are replaced by capital A, capital B, capital C, capital F, capital G, capital H, and L, M, N. So here Y is replaced by M and this is replaced by N, and so on. So this will prompt us to define one type of cone, which is called a reciprocal cone. Now the definition of reciprocal cone, which can be asked in section A: the locus of the normals through the vertex of a cone to the tangent planes is another cone called the reciprocal cone. See, we have a cone. Let this be the given cone, and you consider a plane which of course which passes through the origin, and let this be the generator, which is common to the cone as well as to the plane. That is where the plane touches this given cone. So you have that line, that will be one of the generators which we know already. Now you consider a line perpendicular to that. So this is a line perpendicular. This is the line perpendicular. So when you consider this line, then by when we rotate this like this about the vertex of the given cone, we get another cone. So that cone is called as the reciprocal cone. So it is this line. What is that line? It is the line which is perpendicular to this generator. And how that one comes? It is the line which is common to both the given plane and the given cone. So this is the perpendicular line. The locus of, so when you consider the locus of this, and this one should be fixed. This one should be fixed. So when you consider the locus, what we get is, we get another cone that's called reciprocal cone. So the locus of the normals, this is normal, locus of the normals through the vertex, it should be through the vertex of the cone to the tangent planes is another cone. So the locus of the normals, and it should pass through the vertex of a cone to the tangent planes is another cone. We need to have tangent plane, we need to have the normal, and of course vertex also needed. So all these points should be there in describing a reciprocal cone. The locus of the normals through the vertex of a cone to the tangent planes is another cone called the reciprocal cone. Now the equation of the cone reciprocal to the given cone is obtained in this way. You consider the given cone to be this. Name that as equation 1. Now let the equation of the plane tangent to the cone be Lx plus My plus Nz is equal to 0. Then we know that AL square plus BM square plus CN square plus 2 capital F Mn plus 2G NL plus 2 capital H LM equal to 0. So we shall name this as equation 3. Now the direction ratios of the normal to the plane. So this is the plane. The direction ratios normal to this will be LMN. So because the equation of the plane is like this, the direction cosines are rather become equal to 0. So they can be regarded as direction ratios as well as direction cosines. So when we have that, the drs as such, we will take it as a drs only. Normals to the plane 2R LMN. So this is normal, this is the normal, and direction ratios of that are LMN, and it passes through the vertex. So if we know a point, and for a line to be determined, equation of the line is to be determined means we must know either DCs or DRs, and a point on it should be known. So if we have like this, then we know already that the equation is given by x minus x1 by L equal to y minus y1 by m is equal to z minus z1 upon n. So this is what we are familiar with, and in this case the vertex, that point is 0, 0, 0. So you will have just x by L equal to y by m equal to z by n. Now the locus of the normals only we want. So in this case you can replace these x, y, z by x1, y1, z1, and equating that to say some k, your x1 will be kl, y1 will be km, and z1 will be kn. So because x1, y1, z1, when you consider this point, any point on this line, it will be there in the, it is the cone with the vertex 0, 0, 0, and this is what we have as the equation of the normal. இதனுடைய locus தான் நமக்கு வேணும். அப்போ locus வேணும்னா இந்த point x1, y1, z1 எடுத்துட்டேன்னா அதை வந்து I can replace by this, but remember that x1, y1, z1 is replaced by LMN, and LMN they satisfy already this equation. So they can be replaced by say that AX1, x1, y1, z1, and dropping the suffix you get the locus. So you get the locus of the normals to be this one, and if you compare these two, they are representing cones only, and this is reciprocal to the given cone. Why? Because this is generated by the generator which is perpendicular to the given cone. So that is the equation of reciprocal cone. Now this is the working rule. Here you will be given the equation of a cone. Now you find the cofactors of ABC, FGH in this matrix and denote them by capital ABC, FGH. So they are nothing but this, which we have already mentioned. A is BC minus F square, B is AC minus G square, and C is AB minus H square. Capital F is minus AF plus GH, capital G is minus BG plus FH, and capital H is minus CH plus FG. So with this, the required equation of the reciprocal cone is this: AX square plus BY square plus CZ square plus 2FYZ plus 2 capital GZX plus 2 capital HXY, where capital ABC, FGH stand for this. So this is the work.